Happy morning all. I, Dr. G. Myvizhi, Assistant Professor, Department of Chemistry, Vellalar College for Women, Erode. In this module, I am going to talk about polymers. These are the contents I am going to talk. Introduction, types of polymers, classification and its characteristics, and finally applications. So first, what are polymers? Polymers are very huge molecules made when hundreds of monomers, that is small molecules, join together to form a long chains. Not all polymers are plastics. For example, ethylene is a monomer which converted into polymer called polyethylene. And these are the types of polymers: natural polymer, homopolymer, heteropolymer, copolymer, thermoplastics, and thermosetting. A polymer which containing the same type of monomer is known as homopolymer, and this polymer type usually implies that the polymer is made from all identical monomer molecules. And heteropolymer, if the main chain of the polymer is made up of a different species of atom, it is called a heterochain polymer. For example, nylon, terylene are the examples of this case. And copolymer, when two or more different monomers together to form a polymer, is called a copolymer, and this polymerization is termed as copolymerization. There are four types of copolymers: statistical copolymer, alternating copolymer, black copolymer, graft copolymer. And the case thermoplastics, a type of plastic that can be softened by heat and hardened by cooling and then softened by heat over and over again. These type of plastics are not cross-linked polymers. Example, polyethylene, nylon and polyvinyl chloride. And thermosetting plastics, thermosettings plastic have the property of becoming permanently hard. Once if we heat it will become hard and rigid when heated. Thermosettings are hard and rigid at room temperature, and it do not soften on heating. Examples of this case are epoxy resin, phenolic resin, unsaturated polyester resins, etc. And this is a next classification of polymer. The polymers are classified, broadly classified on the basis of source, structure, molecular force, and mode of polymerization. Based on the source, it can be subclassified into three: natural polymer, semi-synthetic polymer, and synthetic polymer. And based on the structure, it can be classified into linear polymer, branched chain polymer, and cross-linked polymers. And based on the molecular force, it can be classified into elastomers, fibers, thermoplastics, and thermosetting polymers. And based on the mode of polymerization, the polymers are classified into two. One is addition polymers and another one is condensation polymers. So based on the origin of source, the polymers are classified into three: the natural polymers, which can be obtained from the natural materials like cotton, silk, wool, etc. And synthetic polymers are the one which can be obtained or synthesized by man-made. The examples of this case are polyethylene, nylon, and terylene. And semi-synthetic polymers, these are the polymers mostly derived from naturally occurring polymers by chemical modifications. The examples of this case, rayon. Next, based on the structure, the polymers are classified into 4 linear polymers in which the molecules form long chain without any branches. In the case of branched chain polymer, the molecules having branch that can be connected by 3 or more segments, and cross-linked polymers, which includes interconnection between the chains. And network polymers are the one a cross-linked polymer that includes numerous interactions between chains. And based on mode of polymerization, the polymers are classified into 2 additional polymerization. The same kind of monomers are straightforwardly added together to form a polymer are called addition polymers, and the process is addition polymerization. It is a rapid chain reaction having chemically activated groups. Each reaction set up the condition for another to proceed. It consists of 3 stages. One is chain initiation, propagation, and termination. And the second type of this case is condensation polymerization. It involves a polymerization reaction between 2 different monomers with the elimination of simple byproducts like water, ammonia, etc. In this case, the 2 different monomer A and B combine to form AB with the elimination of byproduct. It involves individual chemical reaction between a reactive monomer. In this case, the byproduct is formed and condensed out. The reaction is slower than the additional polymerization, and it should need a reactive functional group. And these are the some characteristics of this polymer, which are polymers which have low density, good corrosion resistance, good moldability, and low mechanical properties, poor temperature resistance, and it can be produced transparent or different colors. And finally, application of this polymers. So the polymers play vital role in various fields such as medicine, consumer service, industries, and making some sports equipments, etc. Thank you.